My name is Emily Weber, and I'm a machine learning specialist solutions architect over here at Amazon Web Services. Today, we're going to learn how to build, train, and deploy machine learning models on Amazon SageMaker. So let's get started. So today, first we're going to briefly cover how Amazon thinks about machine learning in terms of the AWS machine learning stack. After that, we're going to drill into Amazon SageMaker, and we'll close it out with a demo of SageMaker Autopilot. So let's get going. So first, quick recap on the AWS machine learning stack. So as you remember, AWS is building and launching machine learning services in three varieties. At the lowest level of the stack, you'll see machine learning frameworks and infrastructure, right, which is great for a expert data scientist who is totally comfortable optimizing both their neural network in their deep learning framework of choice, in addition to optimizing the EC2 instance itself. Today, we're going to cover SageMaker, which is one level above that, right, where we're going to see the instances turn on and off. We're going to see a host of features and capabilities built out for us. The top tier of the stack are AI services, where by and large, we're going to interact with them like APIs. So we can send, in the case of computer vision, we can take a JPEG or a PNG, send that up to Rekognition and get a classification response. Or we can bring our own data in terms of customers and items that they like, and then build our own recommendation system using Amazon Personalize or Amazon Forecast for forecasting. But today we're going to focus on SageMaker. And so to cover SageMaker fundamentals, first we want to understand about a managed development environment. So that's where SageMaker begins. We're going to talk about SageMaker Studio today, which is actually going to be decoupling our development from our compute. So both the Jupyter Lab environment that we'll be operating on top of and the notebooks that we're going to run, we can scale those two things separately and manage them separately. So on the one hand, you'll have your domain, which we'll learn about in a second, where you can manage your user profiles and ensure a really nice customer experience. But then separately, your developers and data scientists can get access to more compute, right? They can run larger jobs, they can run more advanced jobs because they can easily upgrade those EC2 instances or run jobs on the fly. We'll also briefly cover built-in algorithms in SageMaker. There are 17 algorithms that we can get our hands on. These are optimized and managed by the SageMaker science team, and we're just going to access them. On top of that, we can bring our own models on SageMaker. And so whether that's scikit-learn, R, Spark ML, TensorFlow, MXNet, PyTorch, Chainer, XGBoost, we can actually just define our scripts and then run that on a SageMaker container. So the way this works is what's called the machine learning training service. What's happening is that we'll be on our notebook instance or on Studio, and we're going to call model.fit the way we always do. The difference is that in SageMaker, we have a new EC2 instance, right? This is a new cluster, a new host that's coming online that is dedicated to our model. Now, this training job is going to be alive for the number of seconds our model is training. The moment that model finishes training, the job is going to come offline and the artifact goes back to S3. After we've trained our model, we can tune it. And the tuner is fully compatible both with the built-in algorithms and when we bring our own, again, scikit-learn, XGBoost, deep learning, all the good stuff. So the hyperparameter tuner is leveraging Bayesian optimization. So we can specify the hyperparameters we want tuned in addition to the number of total jobs and the jobs in parallel. And then the hyperparameter tuner will operate like an orchestrator. So it's going to run n number of jobs in parallel, look at the performance of that model on the validation data, which we do have to bring, and then the Bayesian optimizer is going to pull, again, that validation results and suggest new initializations for our training job. So we can run anywhere from 9 to 20 to 250 training jobs in one single effort to tune the model. After that, we're going to learn how to deploy our model. And so this is actually a single line of code in SageMaker, fully compatible with both the built-in algorithms and cases where we bring our own. And so again, one line of code, model.deploy, and we're going to automatically create a RESTful API around our model. And this is going to be able to operate to real-time responses. So we're going to see single millisecond response times for our models. Not everyone needs an online case. And so we also have batch transform when you want to respond to traffic in the sense of an event trigger. If you're uploading something to S3 or a different time of the day or a Lambda function call, you can easily run a batch transform job. You'll see SDKs in SageMaker, both the Python SDK, the Spark SDK, but also Boda 3, right? You'll see a lot of interaction there. And then obviously our documentation, white papers, and blog posts. And so you might be thinking to yourself, SageMaker looks awesome, but can I really bring my own model? Is that really supported? And the answer is emphatically yes. Yes, you can bring your own model. You're going to have two ways of doing this. So one is called the script mode, where you're going to bring your own model as generally a Python script, right? So that's scikit-learn, TensorFlow, MXNet, Chainer, PyTorch. You'll specify your model as a Python script. And then you're going to use what's called an estimator. And that estimator is basically pointing to our container. So it's pointing to a container that's managed by SageMaker that has your framework of choice. Again, scikit-learn, XGBoost, TensorFlow. You can bring a requirements.txt file for all the extra packages that you need. And it also has a web server, so you can easily, again, deploy that. Another option is using Docker, where you just want to copy your scripts, literally your train, your predict scripts, into a Docker container. So you're going to want to bring a Docker file, set that up so it's hitting the SageMaker ports. And then after that, you're just going to run that on a training cluster or on a serving cluster. And all of that we have extensive examples for, very easy to follow. Another option is that you can even bring a pre-trained model. So let's say you train a model in another framework and you just want to host it on SageMaker, fully supported. Again, you just want to make sure it's in the right format. Generally, we're looking at tar.gz balls, not too challenging to wrap those models in. And those are going to be generally in line with the best open source framework and the open source solution for that model. And so again, we're going to wrap that and then bring that into SageMaker. And so this is SageMaker Studio, right? So SageMaker Studio is based on Jupyter Lab. So we'll see our Jupyter Lab notebooks here. These are Python files. You'll see widgets on the left-hand side. The first one is for your data, right? So you can easily point to the data you're working with, whether that's in S3 or actually just upload it onto Studio. You can bring your scripts. You can run your code right there. The next widget is for Git branching. And so Studio has a really nice Git branching solution where we can easily view the most recent changes. We can stage our changes for commit. We can push those out to our Git repo. We can pull the latest changes. Lots of good stuff there. We can manage our environments in SageMaker Studio. So every time we're creating a new notebook or a new terminal, and we're pip installing all of our packages there, we can actually import that environment directly into another notebook. So very easy to persist those environments. We'll see experiment management. So this little beaker here is where we can actually manage our experiments in SageMaker. All of the jobs that you run in SageMaker will default to showing up. They're going to be under unassigned trial components. But you will be able to attach them to experiment jobs. And so by and large, that's what SageMaker Studio looks like. So the way we're going to set up SageMaker Studio is through either IAM or single sign-on. And so you can easily integrate Studio with an Active Directory setup that you have in your enterprise systems or that you're just setting up in your AWS account. And what you'll see is that your users can easily jump into the Studio environment. After that, they'll jump into their domain, right? And the domain is going to have automatic and or low lift feature access across a wide variety of capabilities, whether that's experiment management, debugging, model monitor, autopilot, endpoint management. There's a whole host of solutions. The good news is that all these features are backwards compatible, which is to say, even if you're running on a notebook instance, you can still use all of these features, right? You just have to write a little bit more code to get it done. So the big difference is just that in Studio, the features are going to jump out of the box a little bit more because there's a crafted UI versus on the notebook instance, it's a little bit more do-it-yourself. You have to actually write, some of the scripts for that. Then, once we have our notebook set up, we're actually going to run them on dedicated compute. So again, every notebook that you turn on within the Studio domain is running on a dedicated host. that's running on a dedicated EC2 instance that you can easily upgrade, you can change out, you can manage the packages, and you can share with other people. So you can click a button, create a shareable snapshot, and then that will create a link which you can share with someone else on your team. So pretty cool. All right. In the event that you are still working on notebook instances, fully supported, right? You've got all of the features and capabilities. The notebook instances are another great way to start on SageMaker. You've got your EC2 instance, right? And we can increase the size of that. We can add all the packages we need to. We can version it. We can manage it. When we need to turn that instance off, we're going to attach an EBS volume to the bottom. That's an easy way to persist your data and ensure that you're holding on to your work. It's common to integrate a notebook instance environment with Lambda, where Lambda, again, will let us automatically manage the environment. So inside of a Lambda function, we can write code to list our notebook instances, to loop through those, shut them down, right? Copy our data out to S3 if we really want to, and do the same thing for our endpoint. So we can easily turn those off. In Studio, you'll see this happening by default, right? Studio, the pricing is actually different. On notebook instances, you'll see a chargeback per uptime, versus on Studio, you'll see a chargeback per utilization. So there's less of a need to turn the instances off in Studio versus where you still really do want to do that for your notebook instances. All right, so the training clusters. So we'll start with our model, right? And that's going to be on a notebook instance, that's going to be on Studio, and we're going to call model.fit. Once we do that, we need to make sure our data is in S3. Now you have a few options for this. You can actually run on an EFS volume if you've got a lot of data sitting there. You can also run in an FSX for Luster. So when you have larger data volumes, anywhere upwards of 20 GB, it's really helpful to actually put that in an FSX for Luster file store. I saved about 20 minutes in my training job on 100 gigs of data just by landing that in FSX for Luster. And so SageMaker is, again, turning on a new EC2 instance, or a number of these. And these are going to be dedicated to our model. And these are up, right? These are up for the number of seconds our model is training. After the data lands on that instance from S3, we're also going to see the Elastic Container Registry coming into play. And now ECR is hosting the image, right? It's hosting the script, it's hosting our packages. And what we want to do is just point to that image so we can land it on this cluster. And so ECR is actually going to download that Docker container onto that host. And then again, this is going to run, right? This guy is up for the number of seconds your model is training. The moment this finishes training, your trained model artifact is going to be written back to S3, and then the job completes, right? Everything comes down. That's why the training clusters are really nice, because on your notebook instance, you can use a much smaller EC2 instance, or for Studio, you can run on T2s, T3s, but then for your training jobs, you can scale these up dramatically. You can run on the P series, the C series, you can have, tens of nodes in your cluster, all orchestrated from a single notebook instance. So pretty powerful. After we've trained and tuned our model, we want to deploy it. And SageMaker lets us automatically create a RESTful API around our model. And this is a single line of code, right? Particularly when we're using a built-in algorithm or script mode, where in both cases, SageMaker is going to provide a web server. It's going to bring all the code for the web server, and we get to use that, again, just by saying model.deploy, and we'll automatically create this RESTful API. Now, your endpoint has auto-scaling out of the box. When you enable multiple EC2 instances, you'll see those over multiple AZs to ensure high availability. Those are going to be managed by a load balancer. So your load balancer is looking at the traffic, making sure that your instances are healthy, and then actually calling model.predict on your model using your code, right? Those are actually sitting on those hosts. And so that's going to respond. You'll typically see your endpoint integrated with a Lambda function. This is a common pattern that customers tell us is helpful, so that they can connect their API gateway to their endpoints in a really seamless fashion. And then your client application can be a huge variety of things, right? You can be running a connected vehicle setup where you're hitting, SageMaker endpoints in the cloud. Or maybe you're working in agriculture, or maybe you're working in connected factories. You might have a Node.js application. You might be building a solution that's hosted on-prem and then hitting your resources in SageMaker. In all of those cases, all we need to do is package up our request as an API call, right? We're just going to land that in JSON, and then shoot that out to our SageMaker endpoint and get our response back. It's very helpful to develop a multi-account strategy. And a multi-account strategy means we need multiple AWS accounts, right? So on the right-hand side, we have a data science account. And this is where your teams are going to be developing models. They're going to be training them. They'll be testing out solutions. And once they've found a model that they're happy with, they'll kick off an automatic process. And typically that's by landing their artifacts in another S3 bucket. Then you're going to have a continuous integration, a continuous deployment solution, pick up those model artifacts from your data science account and promote them, actually move them up to a shared services environment. That shared services environment can be a DevOps account, you can call it an MLOps account. Typically what we see is that customers will, again, pick up those artifacts and then run a test. They'll turn on an endpoint, they'll run a batch transform job, make sure that your artifacts are in the right place, and then actually promote them into production. In your production environment, it's common to see this not have console access. You'll see very high security postures here, all deployed via CloudFormation. In this case, we actually were designing for high throughput, low latency. This was a flight recommendation case, and so we had 3 million requests per hour. And so the single request was a customer ID. And so a customer ID would come in through API Gateway, hit this Lambda function, which we initialized with higher reserve concurrency to handle the latency and throughput. And then that actually connected to Redis. And so Redis Elasticache was hosting the features. So the actual variables themselves, the X variables, were stored in Redis. We also stored the Y model response. So the predictions themselves were sitting in Redis. And then we could respond with a prediction request immediately. Now, the upside of doing this in Redis is that the response time is just going to be faster, right? You're going to see response times in under a millisecond, sub-millisecond response times for Redis Elasticache. Now, SageMaker is still fast, right? You're still going to see your SageMaker endpoints responding in single-digit milliseconds, but it is hard to beat that sub-millisecond response time. And so we actually integrated a solution with both Redis Elasticache and SageMaker across multiple accounts. And so this is the way to go for deploying models into production, is across multiple accounts. Now, I'd love to talk you through some of the launches that the SageMaker team pushed forward in 2019 for re:Invent. So the first one, of course, was SageMaker Studio. We learned about this. Also, experiment management. So in SageMaker, you can easily manage your experiments. We can run processing jobs, so you can easily turn on new instances, run feature transformation, and then turn those off. We have a debugger, so now you can analyze models that are training, debug these. You can run autopilot jobs over both regression and classification. We can connect out to Kubernetes, so we have full connection with SageMaker operators for Kubernetes. You can monitor models in production. So when you have a running endpoint, you can easily integrate model monitor into this environment. And multi-model endpoints. So now you can run multiple models on a single SageMaker endpoint at a fraction of the cost than would typically have been incurred. And lastly, augmented intelligence. And so you can connect a SageMaker endpoint to a data labeling job. Actually, so when your endpoint response is milquetoast, it's in a confidence level that you're not really happy with, then you can trigger manual review. You can have a team of people actually look at that data object and then correctly classify it or provide the right label. And then it'll go back into the rest of your training data so you can improve your model. And so SageMaker Autopilot works like this. We're going to start with our data in S3, and then we just need to pick our target column. We actually just need the header in Autopilot, and we just need to specify our target column. And then we're going to run it on SageMaker. And Autopilot really handles the rest. Autopilot is generating notebooks for us. So we're going to get a data exploration notebook, a data transformation notebook, or script rather, and then candidate generations. And so we'll see unique feature engineering strategies associated with unique model tuning strategies. And all of these will, run automatically for us, or we can just get the candidates and then we can run those through ourselves. Autopilot comes with a really nice visual. So you'll see this dashboard that shows you which stage in the process your job is at that point in time, lets you easily access your notebooks, and then view your artifacts and your resources. Here's a case where I was working with a customer on shipment date estimation, where they were receiving orders from their customers and needed to provide a shipment date, and their on-prem system could be months off, right? It was not where they wanted it to be. So we plugged this into Autopilot, and on our first try, on the first time we plugged this into Autopilot, the results were astonishing. Our RMSE was 69. And then when we aggregated this to the week level and looked at these predictions over the course of a year, I mean, you can see, so the orange line is the actual shipment date for the orders, but the blue line is what Autopilot predicted. And across this variation like this, where some weeks we're looking at orders over 25,000 days in the future, again, aggregated over all the orders at the week level, versus some of them are, not even hitting, 2,500. To get this level of RMSE means we're at less than 1% error. So pretty exciting. We can also add SageMaker debugger hooks to our training jobs. So we're going to start on our notebook instance, and then we're going to want to add this debugging hook, or from Studio, right? Fully compatible. After that, SageMaker is going to run a new training job, right? So we've got this new EC2 instance coming online. We've got the model coming in from ECR, and then the debugger hook is going to be listening to events. And so it's actually recording tensors, literally recording the tensors themselves. Once the tensors show up on that training job, they're going to get landed back in S3. They're actually copied from that cluster to S3. Then a new instance is going to come online. And this new instance is actually applying rules. So it's going to apply rules like vanishing gradients, exploding gradients, loss not decreasing. I can analyze your feature importance. There's a whole host of solutions that come out of the box. Then we're going to download those results to our local development environment, again, Studio or Notebook instances, and then we can analyze them. We can plug those tensors into visuals and get some pretty compelling options. So here is an interactive tensor plot that we can get with SageMaker Debugger. So again, this is just a typical ResNet model. This is just your neural network. And what we see are the starting image, right? So this is obviously a 2. And when it's plugged in through this neural network, we see the blue is where tensors are inactive. And then the pink is where the tensors are active. And then we'll set out all the way here down at the end is with the actual classification. And so obviously this is a really compelling visual to share with your stakeholders who might want to understand in more detail, how your neural network is able to perform. In addition, SageMaker Debugger offers class activation maps. So what's happening is that we're running a training job, we're downloading those tensors, and then the tensors we can plug into this nice visual. And the visual is letting us analyze how the features are being activated. So this was a case of German street signs where, we see this 60 here, but then there's this odd little chair or, rim of a car that is obviously obstructing the image. And you can see with the class activation map that while the model starts training, it actually, for a split second there we go, it actually is picking up that rim as being predictive, but then it moves up and it centers on the street sign. And so what we can do is analyze this, right? And we can use this to improve our model training strategy and our data labeling strategy. Now, we want to learn how to create multi-model endpoints. So a multi-model endpoint lets us host multiple models from the same framework on a single endpoint. So multiple XGBoost models, multiple scikit-learn models, multiple KNNs, and we're going to be able to host these again on a single instance. So when we go to create this, we want to first point to our image in ECR. We want to point to the absolute S3 path. So that is the absolute path where our model artifacts are stored in S3. create the endpoint config, and create the endpoint. The thing to know here is that our model is only going to make it onto the endpoint after we start invoking it. So when we go to invoke this endpoint, right, we're going to specify the name of the endpoint and the target model, and this is the relative path in S3. So we'll invoke that endpoint, and then again, once the invocation starts, we'll see the model is copied from S3 onto this instance. And that's going to be the same for model number 2 and for model number 3. So when you're designing for multiple models on a single SageMaker endpoint, it's helpful to know that you see a little bit of latency in that first model response. That could be in the order of a few hundred milliseconds. And so that first model is going to make it onto that endpoint, and then we'll get the responses. And the subsequent responses are going to be much faster. And then lastly, we want to learn about SageMaker Model Monitor. So Model Monitor is how we can analyze models that are performing in real time. So we'll start with our notebook instance, again, our studio, and we're going to configure our data capture. So the percentage of data we want to hold on to. Then we need our training data, actually. So we're going to grab our training data and we're going to put that onto our EC2 instance. And we're actually going to run a processing job. And so this processing job is learning baseline statistics for all of our features. So for all of the tens or hundreds or thousands of features that you have, we're going to use what's called DQ. It's Amazon's open source toolkit. It's basically unit testing for data. And so we will learn, again, the best baselines for all of your features. You can modify this. You can change this out. You have full confirmation ability, but you'll get this baseline. Then we're going to create our endpoint, right? We're going to launch our resources onto this endpoint, and then we're going to start to schedule monitoring jobs. And so these monitoring jobs are going to come online, and they're going to run on the schedule that we specified below. And then we can analyze those resources, right? So the monitoring images are going to come online. They'll grab the data that we stored and then compare that to that DQ learned threshold that we have. And then we'll take those results back to S3, drop them down to Studio or to our notebook instance where we can analyze and visualize these. And so with that, we'll jump into the demo. All right, let's take a look at the demo. And so I'm on Studio, right? You can see right off the bat that we're in our Studio domain here. I'm going to jump over to the SageMaker console briefly. So this is where I first created the domain. I'm in Ireland right now, and so I first just created the domain. Took probably 3 minutes to do, half that in clicks, and then we get our user profile. And so this is my username, and then I'm just going to open up Studio, and that's right over here. And so again, Studio is based on Jupyter Labs, so you'll see this is our handy dandy IPython notebook that we're going to be familiar with. We'll click on this little widget here for the data. And so this is where the first thing I did was clone the repositories, and that should be the first thing you do. When you're doing that, you can click on this plus button. That's going to open up the launcher, and then I'll just minimize this here. And then when you're doing the launcher, the fastest way to do this is actually the system terminal. The system terminal is going to jump into action, and so you can pwd, right? You can git clone. You can even pip install if you wanted to just run Python there. And then after that, we're going to open up the notebook. So we'll close this out here, and we're going to do our complex maneuver. We're going to do actually a step through, and check this out. So the first thing in this notebook is to just import the SageMaker SDK, and then we're going to set up our job. So we're going to download the data set just with a little wget here. We'll download this banking data set, so for direct marketing. We'll download this, then we're going to drop it into pandas just for a quick view. The target column is right over here for folks who did respond to the marketing campaign. Do a little data split. So we've got our train and test sets. Then we're going to upload those to S3. So now we have this full S3 path with our data, again, loaded in S3. And then after that, we're just going to run our job. So we've got some input and output config specs. Those are listed here. And then we're just going to create the job. And so SageMaker.createJob, Pretty straightforward, pretty easy to do, right? That's probably 4 lines of code right there, plus the name, maybe 5 or 7. And then the job comes online. So we can view it. We'll just open up this experiments view. We'll hit refresh here to make sure we see our results. Then we're going to open up this little widget here, and then right click. Remember, we want to right click in Studio. So we'll give this a right click. Then we're going to describe AutoML job. So we'll close this back out. And so you can see we have a number of tuning jobs that have finished. We can actually sort these. We'll just click descending here on the objective. And so that's our best tuning job with the little star right here. We can right click on this, and then we're going to open in trial details. And so SageMaker Autopilot is associating all of our jobs with an experiment by default. And so we can see the different stages of our trial across tuning jobs, transform jobs, and processing jobs for the actual data transformation. We can also view the notebooks that are generated from Autopilot. So here's the data exploration notebook. So this is just looking at our data sets. It's deciding the machine learning problem right across binary, multi-class classification, or regression. And so we'll just get this nice little analysis notebook. And then we can also open up the candidate generation. And so the candidate generation will analyze our data and then again create unique feature engineering and model tuning strategies. So this first one, DPP0, is an XGBoost. So this is using, first it's transforming numerics with a robust imputer, then performing the one-hot encoder with a robust standard scaler. And so this is going to run, right? And we can analyze this in the AutoML view, which is right over here. We can open up our candidates, and there you go. After this is finished, we can jump into endpoints, which is right down here. Then we can view our endpoints. We can deploy the solutions. Actually, we can just do a right click here and then deploy the model, right? And that'll actually help us create our endpoint. And so that's it. We're out of time. I hope you enjoyed the session. If you want to continue learning about SageMaker, there are great resources with machine learning training and cert, and that's how you can get certified, how you can take instructor-led classes. Again, thank you for your time. My name's Emily Weber, machine learning specialist, SA, based out of Chicago. So if you want to connect with me on LinkedIn, love hearing from folks, and catch us on Twitch. We have a new series called SageMaker Fridays. This is up live every other Friday on Twitch. So feel free to drop in and say hello. Awesome. Thank you very much. Bye.